This is Michael Carano with RBP Chemical Technology and chairman of the IPC's Thought Leadership Program. This is the inaugural year of this great program. IPC is the world leader in the electronics industry supply chain, providing knowledge, training, certification, advocacy, and of course, workmanship standards for the entire electronics industry. IPC's leadership goes beyond just standards and providing leadership through our government relations, bringing up key areas of change that need addressing. And because of this, IPC recognizes that these thought leaders that we've recruited are providing great areas of expertise that many of us want to learn more about. Everything from competition, education, training, workforce development, environmental, and technology, to name a few. We have with us today Dr. Payman Dehghanian, who is a professor at George Washington University in Washington, D.C. He directs the George Washington SmartGrid laboratory, and he received his Ph.D. degree from the Department of Electrical and Computer Engineering at Texas A&M University in 2017. And he received a Bachelor of Science and Master of Science degrees, both in electrical engineering, respectively, from the University of Texas and from the University of Tehran. Now, his research interests include power systems resilience and reliability assessments, power grid online situational awareness, and smart electricity grid applications. He is the recipient of the 2021 Washington Academy of Science Early Career Award, the 2016 Best Engineering Graduate Student in the state of Texas, and the 2015 IEEE HKN Outstanding Young Electrical Engineer Award. Well, you've got quite accomplishments in your young life, Doctor. So, well, first of all, welcome and thank you for joining the IPC Thought Leadership Program and your willingness to share your expertise. So tell me, what are your areas of specific interest, and why do you think that is important for our industry and our members to understand?
Thank you, Mike, for having me and for the invitation. It's a pleasure to be here and share some of the research and development efforts that we are doing at GW SmartGrid Laboratory. The research and development that we have been focusing on so far at GW SmartGrid Laboratory have been on solutions to enhance the resilience of the smart electricity grid. Well, the electricity grid, which is driving our life and everyday functions, is threatened by a wide range of events: natural disasters, cyber attacks, disruptions, and faults. So we need more situational awareness, and we need to be resilient to ensure that the people, the services, mission critical systems, and critical lifeline networks have the electricity needed for daily functioning and for the modern society.
You know, before we go on to the next important question, you brought up something very important, and we can't help but worry about the last few months where there's been several reports of cyber attacks on various financial institutions, meat packing plants, et cetera. You know, just how vulnerable is our grid, currently from such an attack?
Well, there are two different aspects to this. Our electricity grid is getting more and more digitalized. And as you have more digitalization in the electric industry, you are making yourself more vulnerable to cyber adversaries. That is one. The other side is cyber attackers and adversaries are getting smart, and they know where the sources and the points of vulnerabilities are in the electric industry and how to attack so that it can be hardly detected. Okay. So we are vulnerable in all aspects to cyber adversaries.
So based on that, what is the current practice that is, in place now? As you said, it's mostly everything is digitized, all computerized. But what are the limitations of the current practice? And then why is this important and of interest to you and should be of interest to all of us?
Very good. Well, the existing practice, we are focusing on monitoring and control in electric industry. The existing practice for monitoring and control in electric power industry is primarily of a centralized architecture. We have sensors across the power grid, what we call phasor measurement units. They sense and measure some electrical quantities, and these measurements have to be sent over hundreds of miles at distance to control centers. Control centers receive these measurements from these sensors, and then these measurements will be used for monitoring and control functions at the control center to monitor the grid. This practice is vulnerable, and there are a range of vulnerabilities. One is the communication failure. Well, as these measurements have to be transmitted over hundreds of miles through communication channels to get into the control center and to be used in applications relying on these measurements, this communication channels are vulnerable to failures, latencies, and even cyber adversaries. And if it happens, that will compromise the accuracy of the control center applications. So we think eliminating these risks, system monitoring and control paradigms in electric industry should enable fusing the online measurements in a distributed manner.
Okay.
Translating the data to vulnerable information closer to where the data is generated, and relaxing the need for long distance communication of these measurements for control center applications. This is one vulnerability, the centralized monitoring, sensing, monitoring, and control landscape in electric industry. The other vulnerability that we see is the sensors themselves. These phasor measurement units, electronic devices, and the vulnerability is on how they measure electrical quantities, the voltage and current. The existing sensors have only a signal processing algorithm inside them. And this signal processing algorithm should enable accurate measurements all the time, irrespective of the waveforms, whatever waveform that comes in. In electric power industry, there are a wide range of events that may happen. The electric signals may have noise. There might be a bunch of things together happening in electric. And that one signal processing algorithm should still be accurate and fast. And this one size fits all signal processing algorithm within sensors may not be accurate or sufficient, providing online situational awareness at all.
You know, based on these vulnerabilities and what you're studying, obviously trying to prevent these types of issues and complete shutdown or disruptions, if you were in front of our, whether it's in Texas or whether it's in the United States Congress, what would you tell our lawmakers and our policymakers about this issue? Because they're not actually aware. They've heard about it, but they don't really have the deep understanding of the actual, vulnerabilities as you just described.
Mm-hmm. Well, we observe these vulnerabilities, and we are working to develop next generation smart sensors for online situational awareness in electric industry.
Okay.
Smart sensors because these sensors have now a brain. That means some advanced signal processing and artificial intelligence analytics are embedded within these sensors. The signals come in, some signal processing algorithms are working for signal signature, for pattern recognitions, for feature extractions. And then you get to know what types of events is going on in the electric industry, in electric power grid, and then artificial intelligence for event detection and classification. So we are thinking this solution, smart sensors, provides a grid edge mechanism for distributed intelligence. It provides fast and accurate event detection, classification, and high fidelity measurements at all times. We think this solution for distributed intelligence since this can trigger automated control actions as soon as an event is detected, so it enables a paradigm shift from the existing sensing only to future sensing and actuating devices at the grid. And that is how we think this online situational awareness in electric industry and electric power grids can be realized.
Well, Doctor, this is extremely interesting and also informative. As a thought leader and as a member of other councils, we're looking forward to hearing of your continued contributions to this very issue.
Thank you so much. I'm very happy to be a member of the group, the Thought Leader Program, and I hope that I can be a deserving ambassador for the program.
Well, based on what I've heard today, you'll be making major contributions, not just to this industry, but to our safety and security of our country. Well, with Dr. Dehghanian, this is Michael Carano with the IPC Thought Leadership Program.